Hello, everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 9i. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GS Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 15 December in Jaipur, India, and the virtual event is being held through Zoom yesterday and today, that is 16th and 17th of December 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentations and 2 minutes for the questions and answers. On 9 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. In case of any queries or any updates, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for this session. Dr. Jitendra Chandrakant Musle. Sir is a head and an associate professor at Anantrao Power College of Engineering and Research, Pune, India, with over 14 years of teaching and research experience in higher education. His expertise spans artificial intelligence, machine learning, deep learning, cybersecurity, IoT, computer vision, and generative AI. He is committed to advancing release, fostering innovation, and guiding students in emerging areas of intelligent systems as well as secure technologies. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Yes. So let's, as per the schedule, we can carry it out with our work. So we will start.
Okay. So, first we have Devesh Kumar to present his paper titled Optimizing 180 nm NOMS Performance, a CCAD driven framework for enhanced circuit design. Are you there, Devesh?
Yes, ma'am. Yes,
Yeah,
I'm
yes,
there.
sir. You may
So,
please
should
start
I
us.
present? Yes, should I share my PPT?
Yeah, you can share your PPT now.
Yeah. One minute.
Before we are just starting, can you please tell me which number paper is there? So I think so. We
1440. Paper ID is
have
1440.
Sir, it's the seventh number in the sequence. After this, all the papers will run in the sequence except for this one.
Actually, sir, I am having my exam duty, so I have requested Anshika to present it at first position.
Okay, no problem. Just
Yeah.
before that, tell me, Ashika ma'am, please tell me, so sequence of that particular
Yeah,
paper. So I'm
sequence
just
is
getting
seventh.
that.
Seventh.
Okay, yes. Thank you. Yes.
Okay, thank you.
Yes, very good afternoon, sir. Here I'm going to present my research conference paper on optimizing 180 nanometer and most performance TK-driven framework for enhanced circuit design. And the introduction part is that is NMOS transistor. These are the fundamental devices in the modern integrated circuit. Basically, there is a need of advanced NMOS so that their speed can be increased and the power consumption of the circuit should be as low as possible. And I am also working on the designing of the low noise amplifier circuit in which we require the most which is having a very compact size as well as the linearity should be as high as possible. And if we talk about the NMOS which we are using in the low noise amplifier, we need that the circuit should consume low power, and so there is a requirement that the saturation region should be obtained before at the low voltage, and that has been done in this paper. So high electrode mobility enables fast switching Performance optimization is essential for low power and high speed application, and we have used use tools like the Silvaco TCAD tool for the NMOS optimization. So tools and methodology: that TCAD simulation using Silvaco, Athena, and Atlas. Process simulation with Athena, and electrical characterization has been done using the Atlas. And we have done the analysis of drain and transfer characteristics of the MOS. So what we have done that is a P-type silicon substrate with more boron doping and silicon dioxide layer for the isolation, phosphorus implantation for the N-type region, and for the contact we have doped the aluminum at the source, drain, and gate terminal, and this has been done using the 180 nanometer CMOS technology. Yeah. So NMOS device structure that we have defined the gate, drain, and source region, the channel optimized doping profile, and net doping distribution analyzed, and structure is suitable for the TCAD electrical analysis. So as a figure is showing, we can see that this is the N channel enhancement MOSFET, and the silicon SiO2 polysilicon aluminum electrode given, and the net doping, that is what we have done, that is a boron doping we have increased, so there is a changes in the characteristics of the MOSFET. So drain characteristics, that is ID versus VDS, it is simulated for the VGS values of 1 volt, 2 volt, and 3 volt. And it has been observed that the linear region observed at low VDS, and saturation region at higher VDS. So higher VGS results in the higher drain current, and the cutoff triode and saturation region that has been identified, and which it can be shown in the figure 2, that is the drain characteristics using the Atlas software for the different values of VGS 1 volt, 2 volt, and 3 volt. So the drain current that is showing on the y-axis, that is in ampere, and the drain voltage, that is the drain to source voltage, that is at the x-axis. And it can be seen that at the lower voltage we are having the linear region, that is we say it as the ohmic region, and after that there is a saturation region. So that because that is increasing ID with respect to VDS, so that is due to the channel length modulation effect. And the transfer characteristics that is observed for the ID versus VGS, at the drain voltage that we have fixed for the 0.1 volt, and gate voltage has been varied from 0 to 3 volt. So gate current increased rapidly after the threshold voltage, and we know that the threshold voltage, the voltage uh, at which the channel is created between drain and source, and after that the current increases if we increase the voltage. So drain current increases rapidly after threshold voltage. It demonstrates the strong gate control, and that is very important for switching and amplification purpose. So this figure is showing the transfer characteristic, that is ID versus VGS. And I want to say that the during this simulation, we first specify the contact for the gate as n poly, and that is has been set the interface parameters. And for this, the temperature has been set for at 300 Kelvin. Yeah. And the gate voltage varied from 0 to 3 volt, and we have taken the step size of 0.25 volt. So that is a transfer equation. So key result, that is a channel doping significantly affects NMOS performance, and it has improved the drain current with optimized parameters. So And TCAD enable accurate prediction of device behavior and results that are useful for the analog and digital circuit design. So if I say that the findings that highlight the need of the careful control over these parameters for improving the efficiency and reliability. The analysis of drain characteristics yielded important insight into the operational reasons of NMOS transistors such as cutoff, triode, and saturation region for the switching applications. And same way we can say that the transfer characteristics demonstrated the sensitivity of drain current to the gate voltage. So this study demonstrates the robustness of Silvaco TCAD tools, including Athena and Atlas for the simulation of complex semiconductor devices. Uh, so this paper lays the groundwork for the future research aimed to address the difficulties of scaling and power management, particularly in the context of new applications like IoT, high speed, and sophisticated computing systems. Yeah. So these are the key result, and the applications are there are various applications we can use this NMO. We use this NMO in the digital circuit, in analog circuits, and for the power management IoT. So these are the main applications. So conclusion: TCAD is an effective tool for NMOS optimization, and drain and transfer characteristics provide deep performance insight, careful control of doping and voltage, foundation of the future work scale, CMOS technology. Yes, thank you.
Presentation, sir. Sir, do you have any questions?
Yes, yes. Thank you. Sir, I'll just would like to ask you, how
Hmm.
does this ticket simulation assist in the optimizing NOMS transistor performance?
Sir, actually, there is one feature that we can change the boron doping, and accordingly, it tell about that where are the requirement. So, depending on we can change the boron doping.
Okay.
Yeah.
And second question, I would like to ask on the which parameters are affecting the electrical characteristics of whatever you are just saying that 180
Yes,
NEMOS
180
devices.
nanometer. That is the CMOS technology. Yeah, and basically, if we talk about nowadays, that is the Apple is working on the 6 nanometer technology, and GPDK. We are using here the GPDK 180 nanometer technology. SCL Chandigarh is also using the SCL PDK. That is as we are moving towards grading down the this nanometer technology, so the power consumption of the circuit that get decreases. But as or we can say that if we say there are various effect, that is a parasitic capacitance plays a very important role. So many other characteristics. So always when we improve one parameter, the other parameter get degraded, because there is always a trade-off between these parameters. So that is a very challenging task, that we have to optimize all the values.
Okay, 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 okay.
Yeah.
Fine, fine. Thank you so much.
Thank you so much. Thank you,
Thank
Anshul.
you. Thank you so much for your presentation. We'll
Thank you.
be
So,
moving.
can I leave?
Yeah. No problem.
Thank you.
Uh, Next, we have Jaya Mabel to present the paper title Adaptive Fuzzy Logic in Irrigation Control Using Real Coded Genetic Algorithm Optimization. Are you there, ma'am? Are you there, ma'am? Are you there? Okay, we'll be moving on to the next presentation then. Next, we have Chinmay to present the paper title ALTS Adaptive Load Balance Task Scheduling Technique to Reduce Task Execution Time and Improve Resource Utilization in Cloud Computing. Are
Yes,
you there?
ma'am. Thank you, ma'am.
Yeah. You may please start with the presentation.
Yes, ma'am. Ma'am, is it visible?
Just give me a moment, I'll check. Yeah, it is visible now.
Okay, ma'am, thank you. Good afternoon, everyone. We are a group of five final year BTech CSE students from Kalinga Institute of Industrial Technology, Odisha, working under the guidance of Dr. Minaki Rao, and we present our research on task scheduling in cloud computing.
Using the differential evolution algorithm, a population-based stochastic search optimization method inspired by natural selection, the project investigates optimizing job scheduling for cloud computing. In order to achieve optimal resource consumption and minimize the total execution time needed to complete all jobs, task scheduling is essential. In unstable cloud system, traditional scheduling techniques like round robin and fast sort are ineffective. Although more advanced meta-heuristic techniques such as particle swarm optimization and genetic algorithms have demonstrated superior performance, they are equally beset by premature convergence problem. A potential solution is provided by this method, which effectively handles complex optimization problems such as task allocation in cloud computing. A mathematical model for the problem is presented in this article. Cloud computing offers scalable and flexible resources for executing modern applications, but efficient task scheduling remains a major challenge. Proper allocation of tasks to virtual machine is essential to minimize execution time, reduce cost, and satisfy quality of service and service level agreement. Cloud environments are dynamic and heterogeneous, while virtual machines having varying capabilities and workload. Poor scheduling leads to resource overutilization, underutilization, and increased maximum. Traditional algorithms such as FCFS, round robin, and min-min toggle will scalability in large cloud systems. This project investigates differential evolution as an optimization approach to achieve distribution and minimize maximum.
First come, first serve, or FCFS, is simple but often results in high make span and inefficient resource usage. Round robin scheduling ensures fairness, but it ignores task execution time and virtual machine capabilities, which reduces efficiency in heterogeneous cloud environments. Min-min and max-min algorithms aim to reduce completion time. However, they frequently cause load imbalance across virtual machines. Heuristic-based methods are faster but struggle to perform well in large-scale and dynamic cloud environments. Overall, traditional scheduling techniques lack adaptability and scalability, making them unsuitable for modern cloud systems. These limitations highlight a clear research gap. Existing approaches fail to balance make span minimization and load balancing, and many suffer from premature convergence in dynamic environments. Cloud systems require scheduling algorithms that are both adaptive and scalable. Differential evolution provides a strong global search capability with fewer control parameters, making it effective for complex optimization problems. Therefore, this work is motivated to develop a differential evolution-based scheduling approach that achieves reduced make span, balanced workload, and stable convergence in cloud environments.
So this slide explains the overall workflow of our proposed methodology. We begin by initializing a set of computational tasks and heterogeneous virtual machines. An initial task VM assignment is generated using a heuristic approach to avoid post-starting solution. The core of our method is differential evolution, where task assignments are optimized by applying mutation, crossover, and selection based on scheduling performance. This optimization process is repeated over multiple generations, and finally, the best task VM allocation with reduced make span and balanced resource utilization is selected. So this slide represents the mathematical foundation of the methodology. Here, make span is the primary fitness function to measure the total execution time. To ensure balanced workload distribution, we use the phi function, which quantifies load imbalance among virtual machines. These metrics guide the differential evolution process in selecting better task schedules at each generation, leading to gradual convergence towards an optimized solution.
This slide explains the simulation environment and the experimental setup used for implementing the proposed scheduling approach. In this work, we simulated a cloud computing environment using Python under the IIS model. We considered multiple heterogeneous virtual machines and tasks with different execution time to represent real cloud workloads. To optimize task to virtual machine allocation, we applied the differential evolution algorithm with adaptive parameters, and the performance was mainly evaluated using the makespan and a load balancing metric called the phi function. Now, coming to the results. This line graph shows the optimization progress across generations. The blue line represents the make span. Although there are small fluctuations, we can observe an overall decreasing trend, which indicates improved scheduling efficiency. The orange line represents the phi function, and its reduction over generation shows better load balancing among virtual machines. Overall, this confirms that the proposed approach achieves reduced execution time along with balanced resource utilization.
Moving forward, this work can be extended by combining differential evolution with machine learning and reinforcement learning techniques to make task scheduling more intelligent. Energy aware scheduling can also be introduced to reduce power consumption and support green cloud computing. Adaptive tuning of algorithm parameters can help the model converge faster under dynamic workloads. Additionally, this approach can be extended to edge computing and multi cloud environments. Finally, real time task scheduling can be explored to make the model suitable for practical cloud applications. To conclude, this study shows that differential evolution is an effective technique for task scheduling in cloud computing. The proposed approach significantly reduces mix span while maintaining balanced workload distribution across virtual machines. The phi function helps in accurately measuring and improving load balance. Adaptive mutation and crossover strategies ensure fast and stable convergence of the algorithm. Overall, the results confirm that differential evolution is well suited for scalable and dynamic cloud environments. Thank you all.
Thank you so much for your presentation. Sir, do you have any questions?
Yes. I have a question. So this group will be for the load balancing, right? So I'll just need to ask about the which challenges they are facing while taking the task scheduling with the cloud environment.
Sir, mainly the most of the challenges that we are facing are schedule are written here. That we have to balance the resources according to the virtual machines that we have. Like if we have a heavy task, then we need the virtual machines according to them. We have to align the task according to the virtual machine so that there is no overload on our cloud.
Okay. And the second question, which are related to the resource utilization in the cloud computing, is there any alternative? Have you checked it out for the adaptive load balancing?
Sir, for example, we have read the previous studies that was done by previous authors. These were the techniques used by them. The FCFS, round robin, mean, max mean, everything, all the limitations are also written here. The main thing we are facing here is they are not optimizing according to the problem statements given. Like some is managing the VMs but not the task, some are managing the task but not the VMs. And many of the modern technologies that we are using, they are very computationally heavy. So looking at all these tasks, we have formed this ALTS.
Okay, ma'am. Okay. Thank you. Thank you so much.
Thank you so much for your
Thank you very much,
presentation.
sir. Thank you, ma'am.
We'll be moving on to the next presentation now. Next, we have Prithvi to present his paper titled An Innovative Approach for Identifying and Mitigating Hate Speech on Digital Platforms. Are you there,
Yeah, hi.
Prithvi?
Yeah, hi, ma'am. Am I
Yeah.
audible? No?
Yeah, you are audible. You may
Thanks.
please share your screen.
Yeah, sure. One sec. Is my screen visible?
Mm. Yeah, your screen is
One sec.
visible. You may please start.
Yeah. So good morning, good afternoon, everyone present here. I am presenting a work titled An Innovative Approach for Identifying and Mitigating Hate Speech on Digital Platform. So with the increasing volume of online user-generated content, hate speech and toxic behavior have become major challenges. Our work focuses not only on detecting such content, but also mitigating it intelligently using NLP and machine learning languages techniques. And area for motivating scenarios for us is basically online platform like social medias, forums, and comment sections face a basically constant influx of toxic and harmful comments. Manual moderation is very slow and inconsistent and scalable. Our work applies machine learning and natural language processing and transformed based model to automatically classify and mitigate that particular comment available on that social media or forums on out there. And our project objective is to basically classify online comment whether they are whether they are क्या बोलते toxic, non-toxic or obscene. We classify based on three things. And to classify online comment, we use traditional machine learning and deep learning APIs. And to compare all the models, we use a naive-based logistic regression, SVM, and random forest. And to leverage, we are using Distilbert as of now because it is very lightweight and very fast as compared to other machine learning algorithms. And to evaluate or different models, we are using ROC, AUC, and response time. And finally, to assess real-world feasibility for live moderation systems. And these are the comparison between both the existing approach and proposed approach. So existing system often suffer from shallow contextual understanding datasets bias and scalability issues are there. But our approach is hybrid, combining traditional machine learning algorithm also, and we are using Distilbert both combined so that we can get accurate, fast, and immediate response for that toxic comment available on that social media platform or any comment section available. So, and these are the formal definition, like what we do, like first detect, then we classify whether the comment is toxic, non-toxic, or obscene, and then we mitigate that thing. Solution for that approach. Our system begins with a multi-platform comment collection using API and web scraping. Through web scraping, we scrape all that comment from that particular social media platform, and the text undergoes pre-processing such as normalization and tokenization and stopping word removal, and then we follow a dual path approach, traditional machine learning trained on TF, IDF, and Distilbert API for high accuracy real-time classification. And this is the block diagram for our project. First, the input is our comment. Then that particular comment is undergone through that data pre-processing module, where text is clean, the whole comment section is clean, and data tokenization happen, and stopping word is removed. From that, we use lemmaization and feature extraction from that particular that comment section that we get processed module from that previous step. And after that we counter the response whether we differentiate whether that particular word is or whole comment section is non-toxic or toxic or obscene. And here is the mitigation framework, how we are different from others. Like first, what we use three-tier classification system. First, safe, allowed without intervention. First is the safe category, and other is unsafe. Triggers, we trigger a warning for or account for a review, and obscene is automatically removed as per our development part. The automatically it is removed from that particular social media platform. And our goal is to not censorship, but smart and proportional intervention that promotes healthy discourse. So these are the details of how we tested that models. So we use the social media comments over like 5 lakhs comments and scraped for the analysis, and we converted that whole thing into a data set. And that when we tested on different machine learning algorithms, and we got an accuracy for 85% for digital BERT, and precision is about 90%, and recall is about 80%. And from that particular data set, we removed all that stopping word, and we did tokenization, and around 15,000 stopping word we removed from that particular uh, data set. This I explained. And this is the comparison between all the in-house model and the API-based model. And this is the we are differentiating based on speed and performance, and the API based model, and this is in-house model. So API based model has a higher speed as compared to in-house model. And talking about the performance, though that traditional machine learning algorithm has a better performance than that API based, but we need faster execution and faster mitigation. So we are using distal BERT as of now. This is a comparison of different models for accuracy, scalability, and flexibility. And these are for outdated model, which has less accuracy, scalability, and flexibility. And we are using that API based, which is not that much, but it is balanced as compared to in-house model and outdated model. And this is efficiency comparison, where both for API based and in-house model, the one we used API based has a better efficiency as compared to the in-house model. This I explained. And conclusion, so uh, we developed an end-to-end system for hate speech detection and mitigation both. As of now, they're doing only classification, and we are doing both hate speech detection and mitigation both. And by combining both machine learning, NLP based, or both, we are combining, and for more accuracy, more fast mitigation part. And yeah, this much. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
Yes. Can you please move on to the first slide, please?
Yeah. Which one? Future area of work?
Yes.
Yeah,
No.
yeah,
First slide.
yeah.
Okay. This belongs to which paper number?
Sorry.
Yes.
Sorry, what did you say? Can you repeat once again?
Which paper number is? Paper number?
Innovative approach for identifying, wait, I will say once.
Paper number 3 in the sequence.
Okay, 3 in the sequence. Okay.
Yeah.
Okay. Can you tell me what techniques are commonly used to detect the hate speech in the online content?
Basically, it is only BERT model we are using. Other than us, like they're using BERT model or a traditional and like machine learning algorithms they are using, which is very slow as of now.
Okay. And
Yeah.
as compared to the means old model,
Yeah.
so what's the new model will trying to reducing the
It is
speech of?
basically distilled BERT we are using, which is very lightweight. We tested both, like the traditional models and the new model, that is distilled BERT. But the difference is both have same efficiency and accuracy both, but the time taking for mitigating and classification, it is more for that older models, and compared to distilled BERT, we are using that thing, because older model we tested, it is around some 9 hours or 10 hours they are taking for to classify, only for classification. But for distilled BERT, what it is happening, like it is around 2 to 3 minutes we are classifying, and after that we are mitigating that particular comment.
Okay. Fine.
Yeah.
Thank you so much.
Thank you so much for
Thanks,
your
sir.
presentation. We'll be moving on to the next presentation. Next, we have KVDS Pragna to present the paper titled CBIT Connect, an AI driven mock interview system for candidate evaluation using multimodal deep learning. Are you there?
Yes, ma'am, yes. Just give me a second, I'll share my screen.
Yeah, sure. Yeah, your screen is visible, Pragna.
Yes, yes. Thank you, ma'am. So, good afternoon, everyone. I'm KVDS Pragna, and I'll be presenting our paper titled CBIT Connect, an AI-driven mock interview system for candidate evaluation using multinomial deep learning. So, the one-line statement for this application is this work focuses on using AI and deep learning to improve interview preparation through realistic assessment and feedback. So coming to the abstract, we know that interviews are critical step in a recruitment, but many candidates lack access to realistic practice platforms. Existing tools do not fully assess communication skills, confidence, and emotional intelligence together. So I think there are very less applications that give us AI-driven mock test up to the par, and they do not have three things. So our system provides an AI-driven mock interview platform that evaluates candidates holistically and gives actionable feedback and a constructive feedback. So motivation behind this website or the application is that job seekers often struggle to prepare interviews tailored to specific roles and job descriptions. So manual mock interviews are time consuming, inconsistent, and not scalable. So there is a need for an automated, adaptive, and intelligent interview evaluation. Coming to the literature survey, uh, to wrap it up in a few points, it is basically for the existing systems, it is a literature survey we have gathered. And based on that, I've concluded that current AI interview systems rely heavily on static and limited data sets. Most platforms generate resume based or HR only questions. And also, many focus only on facial expressions or tone, which is uh, different for different people, and ignoring these can give us deeper conversational context. Frame based analysis misses continuous behavior, reducing accuracy. So these are the literature survey for the existing systems. Coming to the limitations of existing systems, use of their user they use outdated data sets, reducing the relevance. They're mostly restricted to HR rounds, not technical or role specific interviews. And also, they lack holistic scoring that combines accuracy and confidence. They're not fully automated uh, result generation. And also, they have inadequate continuous proctoring, leading to possible malpractice. This is the proposed system. Basically, the proposed system utilizes Gemini APIs to generate up to date interview questions based on job descriptions and requiring skills, ensuring relevance across roles. And also, it evaluates both what the candidate says and how they say it. The system produces a detailed scorecard highlighting strengths, weaknesses, and progress over time, which is very helpful for the person taking interview so that they can assess where they're weak in and concentrate on the weaker points. Uh, and coming to the advantages, up-to-date question generation, as I said before, that it uses Gemini API, so it enables up-to-date question generation and also interview customization. We can customize based on the job description, and also the type of interview we are going to attend. And also holistic score integration is like, unlike the existing platforms right now, it integrates answer accuracy, real-time confidence level calculation by analyzing video frames, providing more comprehensive evaluation. Coming to the problem statement, existing interview systems lack real-time evaluation, continuous monitoring, and integrated scoring. Our objective is to design an AI-driven solution that delivers adaptive interviews, reliable assessment, and detailed feedback while ensuring integrity. And also, data set question generation, how it works is we choose Gemini API instead of static data sets. And also, it ensures real-time industry relevant questions, supports scalability without heavy local storage, allows filtering by topic and difficulty level, and also eliminates the need for manual dataset updates. Dataset for confidence assessment. We use Mendeley facial expression dataset, contains around 4,700 images from 21 candidates, which is adequate amount of data to work on facial expressions and also captured under diverse environments and lighting conditions. Labels indicate confident and unconfident states, and also facial features like eye movement, expressions, and face directions are analyzed. Methodology, basically the system architecture we used in this application are Next.js and React. For front end, collecting job details and handling webcam or mic access, Gemini API for generating interview questions dynamically, Google speech to text converts spoken answers into text, and also OpenCV to capture and analyze facial features for confident assessment. Next, coming to the methodologies also, then this is the flow chart of the technologies we used and how it works. So basically, backend is facial expression analysis and evaluation of answers, and front interface is sign up and login into the application of the website. So these are the results of the website. This is the front page of our website. And as soon as we get press on the get started, we get an interface like this. We need to sign in, and we get a student or the interviewer, the person who's going to take the interview dashboard for the assessment, personality assessment and stuff. Yeah, conclusion is our system significantly boosts interview readiness, enables continuous self-evaluation and skill improvement, stimulates real interview pressure using emotion detection, evaluates both technical and soft skills, making it widely applicable, acts as a strong career development support tool. References, we've referred all these previously existing systems and modified it.
Thank you so much for your
Thank you so much.
presentation. Sir, do you have any questions?
Yes, I have one question. What role does multimodal deep learning plays in the AI mock interview system?
So sorry, your voice is not clear.
What role does multimodal deep learning plays in AI based mock interview system?
So yes, sir. So basically,
Role of
yes, sir, yes. Role of multimodal analysis is that it helps us evaluate candidate more accurately by combining multiple data sources or data sets.
Okay. Only one question for this. Yeah.
Thank you
Thank
so
you.
much.
Thank you so
Thank
much,
you
sir.
so
Thank
much
you
for
so
your
much, ma'am.
presentation. We'll
Yes.
be continuing with the next presentation. Next,
Ma'am,
we have
can I leave the meeting? So basically, I'm having an exam I have to
for
attend.
exam, you can. Otherwise, I request everyone to stay till the closing remarks. Thank you.
Okay, ma'am. Thank you so much.
Next, we have Sneha Kumari to present the paper title Fusion Faculty Student Interactive Online Network, a teaching learning assessment for programming languages. Are you there?
Yes, ma'am, I am here only.
You may please start with the presentation.
Yeah, okay, just a minute. I will share my screen. Is it visible?
Yeah, your screen is visible. You may go on to your presentation.
Okay.
Yeah,
Is it number 5?
it is visible. You may start.
Is it
Okay.
number 5 number?
Sorry, your voice is not clear, sir.
Is it 5 number 5?
Yes, sir. She's 5 in the sequence.
Okay.
Should I start the presentation?
Yes, please.
Good afternoon, everyone. Today, I am here to present our paper Fusion, which is Faculty Student Interactive Online Network, which is basically a teaching learning platform for programming languages. We are a group of 4, myself, Sneha Kumari, Sanjana, Sneha Verma, and Tejaswini Singh. We are doing this project under the guidance of Professor S.R.N. Reddy sir and Kavita Sharma ma'am. So basically, this will be the flow of our presentation for today, starting with the introduction part. Yeah, so we all know that in today's learning environment, e-learning platforms have become a very sorry, let me start it again. As we all know that in today's learning environment, e-learning platforms play a crucial role in our life. We have like these platforms provide us so many features. The online tools, they offer flexibility and allow learners to understand concept anywhere and everywhere. Especially during the corona time, we have seen the importance of these platforms, that when there were no traditional classrooms, we have these platforms to help us in study. And as a programming student, I know the importance of coding, as I know the importance of programming. And with the programming, I know the importance of like the requirement of the practical concept. And with this practical concept, I know the importance of coding in it, like the need of practicing questions. So through these coding exercises, challenges, and assessments, student can identify their weak areas and gradually improve their performance. This process helps us build problem solving skills and prepare learners with the real world technical roles. As after knowing the importance of e-learning platforms, we have reviewed a few research papers to understand more about the papers, like more about the e-learning platforms and programming languages. So basically, these are few papers which we have learned. Most of these papers focused on the learning management systems, how these learning management systems are designed, and what are the need of these systems, and basically what is the need of the learning management system. There are papers like Progmagus LMS, which basically tells about the need of Python programming and how can we make a uh, platform like programming platform which focuses on Python only. And there are a few more papers which we have studied, like these are the papers which we have studied with the limitations which we have found. And along with these papers, we have also reviewed the existing coding platforms like LeetCode, GFG, HackerRank, HackerEarth, CodeChef, and many more. So, and like in LeetCode, we have a practice coding questions, but there is no content to study. And in like platforms like HackerRank and HackerEarth, we have the questions for practicing. Like these are mainly focused on contest and competitive programming, but there is no content to study. And there is also no like content where where a student can start from the basic and learn to till the advanced level. There is a platform GFG which have all the things, like it has theory part and it also have a practice coding questions. But like this platform will not have a material in in a structured way, like where a student can learn from the from the basic part till the advanced level. So after reviewing all these things, we concluded these are few limitations which we need to cover. So first one is that there is not a single platform which specially focused on C or C++ language. If a student want to learn specifically C or C++, they found it difficult because on those platforms there are so many languages, so it is hard to focus on a single language. And there is not a single platform where a student can get all the materials step by step from basic to advanced level, and which is also aligned with the college syllabus. And after that, like there is one more limitation, which is there is a theory part, but the theory part is not related with the real world context, so it lacks in a practical examples. Like the student find it difficult to relate it with the real life. And there is not something for practice where student can practice there, but but they have learned, like they, if they have some assessment or quizzes to evaluate whatever they learned, and like how much they grab through that concept. So these are the limitations, and based on those limitations, we have concluded the objectives, like which is the need for our platform Fusion. So we need a interactive environment where a student can learn from the basic to advanced level, which is specifically focused on the C and C++ language. There is not a like uh, there should be a coding practice integrated with the platform. Like when a student completed any study material, then after that there should be something that the student can practice itself and check how much they have grabbed from the material. Yeah, so after the objective, this is basically the system architecture of our project. So we will in at the starting we will have a at the starting we will have a landing page where it tells about our platform, like basically the name Fusion. After that there will be an option for the sign up and login option. The new users can sign up and the existing users can log in from here. There will be two dashboard, one is for the student and one is for the teachers. And after that the student will have the options like whatever they want to learn, either it is C or C++. Then after that there will be modules like which is from the basic to advanced, like unit 1, unit 2, unit 3, like whatever they want to learn they can choose, it is from the basic or is it from the starting. And except that, like after that it will provide the material, like where student can learn whatever they want to learn, they can choose. There will be PPTs and theory concepts available to study. And after that there will be quizzes and assignment for practice. And also there will be coding questions, like from where the students can practice. And on the other hand there will be a teacher dashboard. Teacher will have the options like they also have the options like whatever they want to, like if they want to create any assignment, update any assignment, or assign a quiz to the students or assign a coding question to the student, they can do it from the here. And after that there will be an option to check the students progress, like how the students have performed in the quiz assignment or the coding questions. So and so basically this is the system architecture or the workflow of our model. And after that basically the result and discussion part. So we aim to develop a platform where a student can learn programming language from basic to advanced. It will have the material to study, it will have coding questions to practice the way, and it also have the quizzes and assignment parts which is assigned by the teachers and the student can solve it. So we have also started our implementation. So basically this is the visuals of our platform Fusion. So this is the home page which shows our name of our platform, which is Fusion. And after that there will be the sign up and login page. The new users can sign up and the existing users can log in from here. And after that there are like whatever they want to learn, they can choose it from the here. Like if they want to learn C programming, they can choose that. And if they want to learn C++, then they can choose it from here. And after that there are units, whatever they want to learn they can start it, they can choose it from here, like it is unit 1, unit 2, like whatever they want to learn they can choose. And similarly in the teacher dashboard also they will see the same thing, like if they want to add material for C they can choose that, and if they want to l- add material for C++ they can choose it from here. So basically this is the teacher dashboard which shows what all the things which teacher can do. So this is the materials, like they can upload material from here. And assignments, like here we can see they can assign any assignment with the title, description, whatever, and the deadline, and the maximum marks for that assignment. After that they can
Sorry to
also
interrupt you, but you have 1 minute to conclude your presentation.
yeah, it almost ended. So basically these are the visuals of our presentation. And after that the future scope, like what are the things we can add, we have thought to add in future. So we will integrate DI and DSA modules in it to make it more interactive and a learner centric experience. And except that we need time complexity and space complexity for the coding questions, so we will also add that. And except that we will add to detect AI plagiarism and code detection, so that if any student copy from somewhere they can like we can check it. So yeah, thank you so much for.
Thank you so much for your presentation. Sir, do you have any questions?
No, I don't have any question. We
Okay.
can proceed further.
So moving on to the next presentation. Next, we have Prishta to present the paper titled Multivariate Time Series Prediction of Energy Consumption Using Recursive Feature Elimination and LSTM KRS. Are you there, Prishta?
Yes, I am here.
Yeah, Brishta, please start with the presentation.
Sure. Is my screen visible?
Yeah, your screen is visible. You may start.
Okay. Good afternoon, everyone. I'm Prisha Bajeli, and I'm presenting our work titled Multivariate Time Series Prediction of Energy Consumption using RFE and LSTM Keras, paper ID 1414. In this presentation, I'll walk you through why next hour energy prediction matters, what data set we use, and how we combine feature selection with deep temporal modeling, and what we observed from the results and sensitivity experiments. This is our contents page. Now moving on to introduction. Energy consumption forecasting has become a practical requirement, especially with the direction smart grids are taking today. The reason is simple: electricity demand is not constant. It changes hour to hour based on human behavior, appliance usage, and many external factors. For grid operators and even at a household building level, short term forecasting helps in better planning and operational control, like managing peak loads, improving energy efficiency, and making systems more responsive. Now, the key point is that household energy data is not just one variable changing over time, it's multivariate. We have multiple signals like power, voltage, current intensity, and submetering values. These variables influence each other and make the forecasting harder than a simple univariate time series. That's why our work proposes a framework that combines two things: feature selection using RFA and temporal modeling using LSTM through Keras. The motivation for combining these is practical. In real data sets, not every feature contributes equally. Some signals are redundant or they are correlated, and which can also add noise. So, feature selection helps reduce the input space and keeps the most informative predictors. At the same time series forecasting needs a model that can learn patterns across time, like repeated daily usage cycles or a short term carryover effects. LSTM is designed to learn such temporal dependencies. About the data set, we have used the UOCI individual household electric power consumption data set, which contains a very large number of minute level measurements over multiple years, from ranging from December 2006 to November 2010. But minute level data is extremely granular and can be noisy for forecasting at the level we target. So we have resampled it to hourly means, which gives us around 35,000 hourly samples. This makes the prediction task more variable and aligns with the real world short term forecasting needs. Our target variable is the global active power, and specifically, we do next hour prediction. Before modeling, we apply a standard but important preprocessing pipeline. Real world energy data often has missing entries. In this data set, missing values are represented with a question mark. We handle that using time based interpolation because we're working with time series and the time order matters. Then we apply min max scaling so that variables are normalized to a consistent range. This is especially important for neural networks like LSTM to train stably. Now, one critical thing for time series work is the split strategy. We use the 80-20 test split, meaning the model is trained on earlier time periods and tested later on later periods. This avoids data leakage. If you randomly shuffle time series data, the model may indirectly learn information from the future, which gives us unrealistically good performance. Next comes the feature engineering. Even with multivariate inputs, short-term energy usage strongly depends on recent history, what happened in the last few hours. So we add gap lag features, specifically lag 1 to 3 hours of the target. This creates explicit short-term memory features that strengthen next hour prediction. After that, we apply RFE with a random forest regressor. RFE works by ranking predictors and iteratively removing the least useful ones. In our pipeline, RFE helps us retain a compact feature subset, k is equal to 9 features, which includes key electrical measurements and the lagged features. The idea is to keep inputs that carry the most predictive signal while dropping redundant ones. Once the features are selected, we train the LSTM model using windowed sequences. For time series deep learning, we don't feed one row at a time, we feed a sequence window. So we use an input window of W is equal to 24 hours, meaning the model sees one full day of hourly context to predict the next hour. The LSTM architecture is intentionally simple and conference friendly to explain. An LSTM layer with 64 units, a dropout layer to reduce overfitting, and a final dense layer to output a single predicted value.
Prisha, are you changing the slides?
No, I'm not. I'm still
Okay.
on introduction. Yeah. Finally, we benchmark against a strong baseline, random forest regression using the same selected features. This is important because if your deep model is compared to only weak baselines, the comparison is not really meaningful. So, random forest is a strong classical ML baseline and often performs very well. With this context, I'll move to the problem and motivation. So the core problem we have addressed is next our household energy forecasting, specifically predicting global active power using historical multivariate electrical measurements. This is important because short-term forecasting is one of the key building blocks for smart grid decision making, things like demand response, load balancing, and smoother renewable integration. If you can predict the next hour reliably, you can proactively adjust control actions instead of reacting after a spike happens. A practical use issue with multivariate inputs is not all features contribute equally. Many are correlated or redundant. That motivates a feature selection step so we can keep a compact set of predictors that actually carry signal. So our approach integrates RFE to LSTM. RFE gives us a more interpretable way to rank and prune predictors. LSTM then learns the temporal dependency needed for forecasting. And finally, to keep the evaluation honest, we benchmark against a random forest baseline and report performance using MAE, RMSE, R square, and MAPE on a split so there's no leakage for future information. I'll quickly summarize what the recent research trends show and where the gap is. In recent years, energy forecasting research has clearly moved from purely classical statistical models towards machine learning and deep learning. Because energy datasets are larger, noisy, and more multivariate, deep learning models, especially LSTM based models, are widely used because they can automatically learn temporal dependencies and capture complex sequence patterns that traditional models may miss. There's also a trend of combining models like CNN, LSTM, or GRU variants to improve either accuracy or efficiency. At the same time, feature selection remains important because compact models are easier to interpret and deploy. Approaches like RFE based selection helps reduce inputs while still maintaining predictive performance, and they're often paired with interpretability or ranking style. Overall, standard practice is to benchmark using MAE, RMSE, MAP, or R square with chronological or rolling evaluation, but gaps still remain in building pipelines that tightly couple feature selection with temporal deep learning while keeping the workflow compact and interpretable. Objectives follow directly from the problem and literature gaps. We aim to provide a KRS based RFE plus LSTM framework for multivariate household energy forecasting. So we combine interpretability from feature selection with temporal learning from LSTM. Second, we perform empirical study on UCI power dataset, but we structure it in a practical way by working at an hourly resolution which matches short-term forecasting use cases. Third, we build a clean pipeline with missing value handling and a leakage safe evaluation strategy using an 80-20 split. So performance reflects realistic future prediction. Fourth, we apply feature engineering and RFE using a random forest regressor inside RFE to rank features and retain a compact informative set. This makes the model input smaller and clearer. 5, we train an LSTM sequence model on windowed hourly inputs so it can
Sorry to
learn.
interrupt you, but you have 1 minute to conclude your presentation.
Okay. And finally, we run a light sensitivity ablation study varying feature count, window size, and lag removal. We start with data acquisition and aggregation. We use the UCI household power dataset and resample minute level readings to hourly values. We handle missing values then and using time based interpolation and apply min max scaling. We split data 80-20 to preserve time order and avoid leakage. Then we apply RFE to rank predictors and retain a compact feature set. We convert the data into windowed sequence and train an LSTM model, and then benchmark against RFE baseline using the following metrics, including sensitivity checks. Um, System architecture. The data source, step one is the data source, which is the multivariate household electric power data set. Then we have pre-processing, which handles missing values. Um, Step three is the train split, and then step four is feature selection, where we explicitly create lag features of the target for recent time steps because short term consumption has strong carryover effects. Step 5 is feature selection using RFE, keeping the feature set compact. Step 6 is where hourly rows are converted into sliding windows. Our input shape becomes 24 by 9, which is fed into LSTM. Step 7 is a prediction model, which is the LSTM network, followed by dropout and a dense layer. And step 8 is evaluation and baseline comparison. The results, we evaluate both models using 4 metrics, as I said. On the top, you can see a comparison table. The random forest baseline achieves very low. MAE is about 0.01654. RMSE 0.0284. R square 0.999. MAP 1.72%. And RFE LSTM. So the main takeaway is that in the current configuration, the random forest baseline outperforms the LSTM. However, LSTM still shows moderate fit based on R square, meaning it captures some signal, but it isn't yet competitive with the tuned baseline. For prediction behavior, qualitatively, the model predictions tends to track the ground truth reasonably well and with minimal phase lag. The advantages. On advantages side, the benefit is the framework connects interpretability with temporal learning. RFE gives a clear ranked subset of predictors, while the LSTM learns temporal dependencies from sequences. So we don't treat feature selection and deep learning as two disconnected steps. The lag features add useful short-term memory. When we remove the gap lags, the error increases, which supports the idea that recent history is a strong driver for next-up prediction. Limitations, the biggest point is performance. The random forest baseline currently outperforms LSTM, and the LSTM has only moderate fit in its current configuration. Secondly, the temporal model likely needs more systematic tuning. We have not included any external drivers like weather occupancy, which may be important for realistic forecasting. To conclude, this work presented a multivariate short-term household energy forecasting pipeline integrating RFE and LSTM. We evaluated our approach using on the UCI household power dataset and compared against a random forest baseline using 4 metrics. The main performance finding is the random forest achieved the lowest test error, while RFE LSTM achieve moderate fit, meaning it captures powerful, meaningful temporal patterns, but still needs improvement to compete. From sensitivity checks, performance stays relatively stable across small variations in feature count and window size, and we retain W is equal to 24 mainly as a reasonable accuracy efficiency trade off. Finally, training was stable, loss curves decrease smoothly, and early stopping helps prevent overfitting, and the final design remains lightweight enough to support real time or edge oriented scenarios. For future work, we see clear directions. We want to include external explanatory variables like weather occupancy. These can improve realism. We also plan to explore alternative recurrent models like GRU for efficiency and BILSTM by LSTM for richer context capture, and also test attention based architectures like transformers for longer range dependencies. We will do an automated hyperparameter tuning, potentially with GA, to systematically close the performance gap between the sequence model and the baseline. Also, we want to validate the generalization by testing on additional household level datasets so the results are not limited to one dataset's behavior. We'd like to deploy it on IoT devices and integrate forecasting in our real-time energy management workflows. With that, these are the differences, and yeah, that's it. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
Yes, I have a question. Can you just tell me why the LLM network suitable for the multi-level time series energy prediction?
Sorry, so I couldn't get you.
Why the LSTM network suitable for the multi-variate time series energy prediction? Why it is suitable?
Because, sir, they are a model hierarchical and long range dependencies in data. So they can capture interactions across multiple scales, while it also can handle complex and related. They can handle complex energy signals which are also correlated, which improves prediction accuracy.
Okay, fine.
Thank you so much for your
Yes, thank you.
presentation. We can move on to the next presentation. Next, we have Shreyas to present the paper title Pashu Mitra, AI powered cattle and breed recognition system. Are you there, Shreyas?
Yes, hello.
Yeah, you're audible. You may please begin with your presentation.
Okay, thank you. Aryan, are you there? Could you share the screen if you are available? Okay, is my screen visible?
Yeah, it is visible.
Okay, welcome everybody. Thanks to ICTCS for hosting this conference. My name is Shreyas Andarlekar. I'm here with my colleagues Mihir Agashe, Aryan Chauhan, and this project is under the guide of Dr. Vaishali Zadav, ma'am. Our title is Pashumitra AI-powered cattle and breed recognition system. So I'll explain what this is all about. Basically, the government has launched an app called Bharat Padushan, in which they plan to basically create a database of all the cattle, cows, and breeds that exist in all of India. So it's basically a requirement for all farmers to register everything that they have in their farm, all the cattle information in this app. And the information is related to, for example, their breed, their weight, their history, their name. So kind of like attaching a unique ID for every cow, which the farmers have to register. Our purpose is to basically help the farmers identify the breeds more accurately and use data driven intelligence to identify the breeds. Because there are a lot of Indian breeds out there, for cross breeds as well. And in fact, the amount of classes that we had to train our model in was close to almost 48. So our goal is to help farmers basically use the mobile app to take a photo of the cow and then identify the breed, and then also register all of the cattle in a proper database using software. So for this project, we have basically used the VIT model instead of the generic usual CNN architecture, because vision transformers architecture are more suited for when data sets are much larger. And we wanted to gather as much as data as possible for this. So we thought that the vision transformers architecture would be the best suitable architecture in order to identify what kind of breed or cattle this cow is or this buffalo is. So it's a very simple system design. The farmer installs the mobile app, it takes the photo of the cow, and then the model tells us which class it is, and it tells, for example, Gir, Nili Ravi, or Jersey cow. And then it will tell the farmer information about the breed, which can be useful. And also, the mobile app also allows features to register all the cows in a proper database and mark it. So they can properly send that information to the Bharat Padushan app, which they need to do in the future. Our model was able to achieve an overall accuracy of 67.1%, but still, most of the time, it gave us a right only. It's not that much for negative attribute, so we were able to deal with it. Some challenges were there with breeds, but that was obviously expected. So, yes, thank you for this presentation.
Thank you so much for your presentation. Sir, do you have any questions? 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 Okay, I expect there are no questions. So we'll be moving on to the next presentation now. So next we have Nimisha Paul to present the paper title Resume Parsing for Candidate Ranking, a Hybrid Semantic and Learning to Rank Approach. Are you there, Nimisha?
Hi, yeah, that's
Yeah,
fine.
okay. Can you please start with the presentation?
Yes, actually, sorry for the interrupt. I don't have any question, so we can just proceed on.
Okay, thank you, sir. Yeah.
Yeah.
Nimisha, are you sharing your screen?
Yeah, presenting right.
Yeah, okay.
Is it visible?
Yeah, it is visible. You may please start.
Hi, good afternoon, everyone. Today I will be presenting our work titled Resume Parsing for Candidate Ranking, a Hybrid Semantic and Learning to Rank Approach. Companies today receive thousands and hundreds of resumes for a single job opening. Manually screening this resume is extremely time consuming, expensive, and inconsistent. Existing application tracking systems rely heavily on keyword matching, which fails when candidates use different terminology, for example, SRE versus DevOps engineer. This system also struggles with flexible resume layouts such as multi-column format or scanned documents. As a result, strong candidates are often overlooked, recruiters spend excessive hours, and the hiring process gets expensive. And it also becomes biased and inconsistent at many times. So I have reviewed some papers, and these are the research gaps that we have found. Several approaches exist in literature, but each has limitations. Traditional methods like TF-IDF and BM25 depend on lexical overlap and cannot capture semantic meaning. Deep learning models such as BERT, sentence BERT improve semantic matching but ignore structured and attributes like experience length or education level. Layout-aware models focus on document structure but are rarely evaluated in real recruitment pipelines. Learning to rank technologies are well studied in information technology yet remain underutilized in hiring systems. Hence, there is a clear gap. No end-to-end solution combine layout handling, semantic understanding, structured reasoning, and ranking. So finally, to summarize the problem, uh, resume formats vary widely and often break traditional parsers. Keyword matching does not reflect true candidate suitability. Structured information is unutilized. Additionally, most hiring tools lack transparency and fairness guarantees. Our goal is to address all these challenges within a single, ununified framework. So the approach we go by is to go beyond keyword matching through four key innovation. First, layout-aware parsing preserves resume structure, including column, table, and scan document. Second, we use domain-specific entity recognition, extracting skills, education, certification, and experience using an HR-focused NER model. Third, semantic representation learning with sentence BERT captures meaning rather than exact words. Finally, we apply learning to rank using Lambda Mart, which optimizes candidates ordering instead of simple scoring. So how this works? Let me briefly explain the pipeline. First, resumes in PDF or documents format are parsed and cleaned with OCR applied whenever necessary. Second, key entities such as skills, experience, education, and certificates are extracted. Third, resume content and job descriptions are converted into semantic embedding using sentence BERT. Fourth, semantic and structured signals are fused together in a feature fusion. Finally, a supervised lambda model generates a lang list of candidates along with explanation. The dataset and pre-processing. We evaluate our approach on a large and diverse dataset. The dataset contains 10,000 resumes in PDF and documents, description across technology, finance, and biotech domain. The resume includes single column, multi-column, table-based and scanned documents. Personally identification information is removed to ensure ethical compliance. Pre-processing includes layout normalization, section segmentation, entity normalization, sentence board, embedding generation, and feature scaling. Parsing and entity extraction. Handling real-world resume is challenging due to layout variability. Our system preserves formatting using such as columns, bullets, and tables, and uses OCR for scanned document. And custom HR-specific nurse model extract skills, organization, degrees, certificates, and experience span. In terms of performance, our NERD model achieves 92% F1 for skill extraction and 95 F1 for contact information, which ensures reliable downstream ranking. Semantic encoding and sentence bird. To understanding meaning beyond keyword, we use sentence bird embedding. Resume section and job description are converted into a dense semantic vector where similar meaning lie closely together. For example, machine learning or ML and AI/ML are treated as semantically equivalent. We apply a section weighted approach, assigning higher importance to experience, moderate weight to skills, and content depth weight to education. This allows us to correctly match resumes even when exact keywords are missing. Future fusion and lambda bar ranking. Semantic similarity alone is not sufficient for hiring decisions. We therefore fuse semantic similarity with structured features such as job title matching, experience level alignment, education ranking, geographic distance, and certification matches. These features are fed into LambdaMart, a gradient boosted learning to rank model trained on human relevance judgment. Hiring is inherently a ranking problem, and LambdaBot directly optimizes for placing the best candidate at the top. Why we choose LambdaBot for this? Hiring, the models we evaluated are RankNet, Light GBM, Ranker, LambdaMart. But LambdaMart is top because optimizes top K relevance, handles heterogeneous feature set, stable performance across domains, and it gives best result in map and recall at 10. So the results, our hybrid approach significantly outperforms traditional baseline compared to BM25 and USBET only methods. We achieve higher precision recall and mmap. Our hybrid model gets a precision of 0.81, recall of 0.77, and map at 0.79. Overall, we observe a 17% improvement in identifying the most suitable candidate. The application study shows that while NER and semantic embedding each contribute individually, the combined hybrid system with LambdaMart achieves the highest performance, demonstrating strong synergy among components. Explainability and fairness. In addition to accuracy, our system emphasizes transparency and fairness. For each rank candidate, we provide explanation highlighting skills, experience, and qualification contributing to the ranking. Sensitive attributes such as gender, age, and ethnicity are not used. We achieve a disparate impact ratio of 0.92, indicating near fairness at the top 10 shortlist level, with continuous monitoring for bias drift. In conclusion, to conclude, we present an end-to-end resume ranking system that integrates layout-aware parsing, semantic understanding, structured feature extraction, and learning to rank. Our approach improves accuracy, fairness, and explainability, making it suitable for real-world recruitment platform. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
Yes, I have a question. Can you tell me what's the ethical concern arise while you are analyzing the user data for the mental health assessment?
It's not mental health assessment, sorry, sir.
It's a 9 number, right? Serial number nine.
No, it's 11.
Oh,
It's
it's
serial
11.
number
Okay, okay, okay,
10,
okay.
sir.
So
10.
10. Resume passing.
resume parsing. Okay, 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 okay. Okay, then I don't have any question.
Okay, thank you, sir.
Okay, thank you so much, sir. Next, we have Jinilba to Parmar to present the paper titled Real-Time Mental Health Detection via Sentiment Analysis and Ensemble Machine Learning Approach for Social Media Data.
Hello, good afternoon. Am I audible?
Yes, Jinil, you're audible. You may please start with your presentation.
Okay, 1 minute. My screen is visible?
Yes, your screen is visible. You may start.
Okay. Good afternoon, sir, and good afternoon, all the participants. My name is Shinal Parmar, and today I am going to present my research work, which is mainly focused on detecting mental health conditions such as anxiety, depression, stress, suicidality using machine learning technique applied on social media text. These all are the outline of today's presentation. So, start with introduction. Mental health issue such as anxiety, depression, stress, all are increasing rapidly across the globe. So, early identification of this condition is very important. However, traditional clinical diagnosis is often time consuming, costly, and not easily accessible to everywhere. At the same time, social media platforms like Twitter and Reddit have become spaces where people openly express their emotions, stress, and psychological struggles. So, this motivates the use of sentiment analysis and machine learning to automatically detect early signs of mental health issues from the textual data. Sentiment analysis is a natural language processing technique that extracts emotion tone from the text that we can find positive sentiment, negative sentiment, etc. Machine learning enables large scale classification of such textual data into meaningful categories. However, mental health detection from social media text faces several challenges like noisy languages, class imbalance, ambiguity of context, sarcasm. And ensemble learning is particularly effective in such a scenarios as it improves robustness and reliability by combining multiple classifiers. Let's move to the proposed work. Our proposed system follows an end-to-end mental health detection pipeline. First, raw social media text undergoes pre-processing. Then, meaningful features were extracted using TF-IDF. Then, class imbalance is handled using SMOT, synthetic minority oversampling data. Then, after multiple machine learning classifiers are trained, and finally, an ensemble voting classifier is used to generate the final prediction. Additionally, we developed a graphical user interface for real time prediction. So for that, our model, we train three classifiers. First is a Bernoulli naive based, suitable for binary feature extraction. Then logistic regression provides stable and interpretable probability estimation for classification. And last is a random forest. Uh, These models are combined using a hard voting ensemble where the final class is selected based on majority of voting. The main advantage of this approach is the reduction of the bias variance trade-off, leading to more stable and reliable prediction across mental health categories. Now, dataset we have used for experiment are taken from Kaggle, and name is mental health sentiment analysis. It consists of textual posts collected from the Twitter and Reddit.
The data is labeled into several mental health categories like anxiety, bipolar, depression, normal, stress, suicidal, etc. The dataset contains thousands of labeled text samples, making it suitable for supervised learning. So, first of all, we have done pre-processing on the dataset. For pre-processing, include lower casing, then removal of URLs, emojis, and special characters. And then after, next step is feature extraction. And for feature extraction, we have used TF-IDF, which is used to convert text into numerical vectors. Then moving to performance measures to evaluate model performance. We used four standard metrics: accuracy, precision, recall, and F1 score. Accuracy measures overall correctness. Precision measures correctness of positive prediction. Recall measures the ability to detect actual positives. And F1 score balances precision and recall. So let's see the performance comparison. This slide shows the comparative performance of all the models. Here, ensemble model provides balance, precision, and recall. Naive performs weakest among all the classifiers, and ensemble improves robustness over the single models. Random forest confusion matrix. Here we can see these confusion matrix correspond to the best performing model. We observe strong diagonal dominance indicating high correct classification. The model performs particularly well on critical classes such as depression and suicidal, which is essentially for real world mental health application. Here we compare confusion matrix of naive logistic regression and ensemble models. Naive shows higher misclassification. Then logistic regression improve class separation. The ensemble model reduce overall confusion by leveraging strength of all the classifiers. Here, this is the GUI we have implement. Here, suppose we input a text, I want to kill myself, then predicted output is suicidal because it is this statement indicate it is a kind of suicide statement. The same pre-processing and TF-IDF pipeline used during training is applied during the inference. Conclusion. In conclusion, we proposed a real-time mental health detection system using sentiment analysis and ensemble machine learning. The system combines NLP processing, TF-IDF features, SMOT, and ensemble learning. Random forest achieved the best accuracy, while ensemble model provides stable and reliable predictions. So this system is suitable for early intervention and mental health awareness tools. Future scope. Here we have used machine learning technique. So in future we can use deep learning methods like LSTM, BERT, etc. And here we have done experiment only on the textual data. So we can think about multimodal data in future also. Thank you.
Thank you so much for your presentation. So, do you have any questions?
Yes. I have a question. And the question will be the same. So I'll already work on this type of domain. So my question is, what type of ethical concerns arise while you are just analyzing this particular mental health assessment?
uh, Ethical. Actually, here we have taken dataset from Kaggle, but if we take any social media post, then security issue will arise in that case.
Okay. Only have you taken a data set? Have you not doing any type of survey in that?
Uh, Already survey is done in my paper, but in my PPT, wait a minute, sir. In paper, we have write survey already. My paper is visible?
Yeah, it's visible.
Yes, visible.
Okay. Okay. And right now I'm working on the same topic in my PhD work. So survey is ongoing. Also, I am exploring deep learning techniques for the same.
Okay. Thank you so much for your presentation then. So should we move on to the next presentation?
Yes. We can just move on to the next topic.
Yeah. So next we have Rahul Rajesh Kumar to present the paper titled Scheduling of Mixed Priority Time Critical Requests Using Deep Reinforcement Learning. Are you there,
Yes,
Rahul?
yes.
Yeah, you may please start with the presentation.
Is my screen visible?
Yeah, it is visible.
So, good afternoon, everyone. Myself, Rahul Rajesh Kumar. Today, I'll be presenting our research on scheduled mixed priority time critical request using deep reinforcement learning. So, in this presentation, I'll be walking through how we address the critical challenge of managing mixed priority data in healthcare networks using a adaptive AI-based approach. We will explore how traditional methods fails in the modern hospital environment and how our deep reinforcement learning model offers a robust solution. So coming to the introduction, in the domain of Internet of Medical Things, especially in hospital ICUs, we are dealing with heterogeneous mix of traffic. One hand, we have critical alarms like sudden cardiac arrest alerts or ventilator failure notification, which requires extremely low latency and high reliability. These are matter of life and death. On the other hand, we have routine updates like periodic temperature logs or software updates for medical tablets. The core problem is that traditional scheduling methods such as first in, first out or strict priority are static. First in, first out treats everyone equally means a critical alarm could be stuck behind a large file transfer. Strict priority solves the latency issue for alarms but can completely starve the lower priority routine traffic, causing system maintenance issue. Our method is our solution that guarantees precision and timeness over wireless network, similar to the wired TSN, which is time sensitive networking standards, but with the flexibility to adapt to dynamic conditions like sudden traffic spikes. So, brief of our solution is unlike the static algorithms that follow a fixed rule book, our solution uses a intelligent agent that learns the optimal scheduling strategies through a trial and error in a simulated environment. Specifically, we utilize an algorithm called PPO, which is proximal policy optimization. Our goal is a joint optimization approach. The agent does not just look at one switch, it optimizes both route and the path and the scheduling discipline. By doing this, we aim to minimize the end-to-end delay for a critical data, reducing jitter and minimizing packet loss. These are some of our objectives. So design and evaluation to build a framework specifically tailored for mixed priority medical traffic, ensuring the unique requirement of healthcare are met. Minimizing delay. The primary target for a priority traffic is reducing the end-to-end delay to absolute minimal. And network efficiency, we are aimed to ensure that while we prioritize alarms, the lower priority flows are not starved. The network must remain efficient overall. The outperform static method. Finally, we aim to demonstrate the empirical that our PPO-based method outperforms the static rules and earlier reinforcement learning methods like deep Q networks, which is DQN, in dynamic network. These are the some of the literature review we have done. So traditional methods, approaches like ILP, which is integer linear programming, or SMT, offers a mathematical guarantees, but are computationally too heavy for a real time decisions. They can't react fast enough to a sudden network storm. Existing RL methods, while RL is popular, many existing work focuses on general wireless networks like Wi-Fi throughput, rather than a specific constraint of medical healthcare TSN. The gap there was a lack of dynamic learning-based scheduling that explicitly handles the mixed critical network of a hospital network efficiently. So these are the algorithms we used to make an intelligent decision. Our RL agent needs to see the network. This is defined by our state space. The agent observes a vector containing queue size, utilization ratio, in transit packets, delivery rates, and based on this, it chooses from the action space. This is a composite action where a action has a route or a path, which is R, and a scheduling, which can be deadline based, EDF, or LIOF, or priority based handling. This flexibly allows the agent to behave like a priority scheduler during emergency and like a early deadline first scheduler during normal loads. So this is the reward model and PPA model we used. The, the brains of the system is the reward function, which guides the learning. We formulate a reward function R total with 4 components. Positive reward, a high reward for every critical packets delivered on time. And penalty, we subtract the points for packet loss, high congestion, and invalid action. And we are using weights as alpha as 1, beta as 1, and gamma as 0.5. And data and simulation setup. So we validated this using a simulation built in OpenAI Gym and SymPy module in Python. A topology is consists of a realistic hospital subnet with 3 end systems and 2 switches. Traffic is generated. We generate batch packets in a batch format from ES1, which is the end system 1, will create a normal priority packets, and that ES2, which is the second client, will generate normal traffic. To ensure the robust learning, we adding a stoichiometric random variation of 20% in the batch size, and this ensures that the agent is not just memorizing a pattern but is learning to adapt unpredictable real world variation. So these are some of the results we have got. This table summarizes the key findings. We compared PPO against all the scheduling algorithms. So we focus on the priority traffic column. So the proposed PPO is the fastest, which is 1.332 milliseconds, outperforming the static scheduling 1.47 millisecond. It's crucial while PPO optimizes for critical traffic. It maintains a normal traffic latency at 2.44 milliseconds, which is virtually identical to the static scheduling baseline. So the takeaway from this is PPO successfully identifies and rushes the critical packets through more efficient than static rules without compromising the service quality for a routine traffic. So these are the some of the comparison between PPO and DQN algorithms. So we have compared our PPO model against another commonly used AI approach, which is deep Q learning. PPO achieves a 30% lower latency for high priority packets compared to DQN, which is 1.4 millisecond, and PPO is 1.45 milliseconds for PPO, and for DQN it's 2.06 milliseconds. And reliability, the packet drop rate for PPO was just 0.3%, whereas for DQN it dropped by 6.1%. And jitter, perhaps the most important for a medical device, is PPO demonstrated 55 lower jitter than a static method. Lower jitter is essential for devices that perform synchronization data streams like remote robotic surgeries or ECG monitoring. So the conclusion is this paper presents a PPO-based DRL scheduler that efficiently handles the complex mixed priority traffic of hospital network. We demonstrated that it outperforms both static and DQN approaches offered. 30% lower latency for alarms and 55% lower jitter for stability. High reliability with minimum packet loss. So the future scopes will be moving forward. We'll be planning to integrate with IEEE 8021 TSN hardware and like time aware shapers, and extending the simulation to wireless 5G and Wi-Fi 6 environments. And these are some of the references we have taken. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
Okay, I have one question. Why is
Yes.
priority handling important in the time critical request scheduling?
So in a hospital we have different equipments, like we have ECG monitor and we have ventilators and everything. So imagine if a ventilator fails or a ECG machine fails due to some issues, and not fails, I mean due to network traffic, we have to give priority for these devices like ECG machine and ventilators. So if it fails, we have to get the notification about the failure with a minimum latency. So we are using a this PPO model, so that it will give more priority to these devices rather than other client devices in the network.
Okay, yes, thank you.
Yeah.
Thank you so much for your presentation. Last, we have Jaya to present the paper titled Adaptive Fuzzy Logic Irrigation Control Using Real Coded Genetic Algorithm Optimization. Jaya, are you there now? Jaya, are you there now? We'll wait for just 1 minute. Jaya, are you there? You were in the meeting. Okay then.
Why not you can just call her, so we will just get an idea.
Yeah, just give me 2 minutes. Jay, you are in the meeting, right? So are you going to present now? Jaya? You are muted. Kindly unmute yourself. Yeah. Can you please? I'm unable to hear you. Are you going to present? Jaya, you are unmuted, but can you please speak? Are any of the co-authors present? Um, Okay, we'll wait for 2 minutes. Mic is not working. Kindly respond in the comment section. Kindly write it in the chat. Jaya, we are not able to hear you. Kindly proceed with the presentation. Yes, Jaya, your screen is shared, but please use the microphone. Allows this time, yeah. Yeah, please allow yourself to speak. Yeah, Jaya, can you please speak?
Yes, ma'am. Yes, ma'am. Able to get
What
me,
happened?
ma'am?
Can we proceed or can
Hello,
we stop over here?
Yeah. Can you please share your PPT and
ma'am.
start
Able to get
presenting?
me, ma'am?
Yeah, we are.
Can I start the presentation?
Yes, you can.
Yes. Very good afternoon, and all present here. I am Jaya Mabel Rani from Savita School of Engineering, Savita University. My paper topic is adaptive physiologic irrigation control using real coded genetic algorithm optimization. Today, everywhere, water is main important source of our life. Without water, we cannot live in our world also. So at the same time, we have to use the water in efficient management with the major challenges in this modern agriculture world. There are different types of algorithms used, just like machine learning algorithms and optimization techniques also used for a efficient water management system. So each and every methods we have some failure advantages as well as disadvantages. So here I have used adaptive irrigation model using fuzzy logic and real coded genetic algorithm for my proposed system. So genetic algorithm adjusts the membership boundaries and rule weights automatically. So soil moisture sense and temperatures, humidity data are used for this simulation. So here this model achieve 3% moisture deviation and about 80% water savings. So just we can see the background and motivation of this paper. Here this efficient irrigation is very essential for our sustainable agriculture under this climate change. So many regions still depend on heavily on fresh water for crop productions. Improving irrigation efficiency is vital for food security as well as water conservation. So here fuzzy logic performs better than fixed threshold irrigation systems. Static fuzzy rules lose accuracy when environmental conditions are changes. So here adaptive control is required to improve the precision and reduce water use. My main objective and contributions of this paper is develop and adopt irrigation control system for sustainable agriculture with the help of integrated physiology and real coded genetic algorithm. So here it automatically tuned the membership boundaries and rule weights by maintaining the target soil moisture under variable environment conditions, reducing the unnecessary irrigation and overall water consumption. So, for improving the control stability, accuracy, and convergence speed by providing a practical framework for smart irrigation management system. Here, this is my proposed system architecture. So here we are using different sensors to get the information from the environment for soil moisture sensor, temperature sensor, humidity sensor, etc. like that. This sensor data give the fuzzy inference module for the falsification and defalsification process. So this will convert the normal numeric data into linguistic models with the help of this various rules, decision rules. Based on these rules, it is going to give the genetic algorithm optimizer technique to fine tune these values for the efficient output. So after that, we are using this. We are giving this fine tune the data. It is going for this activator, irrigation activator. Based on that value, it is going to give proper how much water we need for this. Depends on the soil moisture or temperature or humidity. So this process will be repeated until this get the proper output. So here system input and output used. Here I taken these parameters: soil moisture, temperature, humidity, and irrigation volume. So all these description measures also given. For soil moisture, volumetric water content of soil in percentage taken from the range 10 to 45%. Temperature, ambient air temperature taken in the degree centigrade, and that is the range from 20 to 40 degree. Humidity, relative humidity in percentage for 90%. Then irrigation water applied for cycle in liters, that is from 0 to 3 liters. Then fuzzy logic controller design. The fuzzy logic controller determines the irrigation needs without manual intervention. So soil moisture, temperature, and humidity are used in input variables. At the same time, irrigation duration is generated as the control output. Inputs classified using linguistic terms such as low, medium, and high. Here we use the membership function for this classification as triangular and trapezoidal membership function. Here for diffie classification process to get the crisp output, here used Mamdani inference fuzzy control system. Then based on the rule-based reasoning enables precise and flexible irrigation control. Here there is a trailer membership function. Membership function simply denoted by mu a of x. So here a is the lower value with the numeric input to membership degrees between 0 to 1. Here the parameter value A, B, C are the define the lower, middle, and upper bounds of the parameters. Use optimizing control parameters with the help of code membership boundaries and rules. Optimization minimizes deviation between with random parameter within deviation based on the function. Here the parent selection we use Rowlett wheel selection method. Then we apply the crossover and mutation values. Then real coded genetic algorithm improves the convergence speed and control stabilities. So here he given the simplified genetic algorithm optimization method. Here we taken the input values, initial population, target soil moisturizer, sensor data, and genetic parameters to get output optimized fuzzy controller parameters and irrigation control signal. First, initialize the population, random initialization, random fuzzy parameter set values. Then evaluate the fitness function using f is equal to 1 by 1 plus m target value minus actual values. So next is step 3, select the parent by Rowland method, then apply arithmetic crossover to generate the offspring. Offspring, which means the children. Then we apply the mutation function, selected parameter with the probability value from 0 to 1 to 0 to. Then replace the weakest individuals with the filter offspring. Repeat until mean fitness changes value less than 0.01.
Sorry to interrupt you,
Then
but you have 1 minute to conclude the presentation.
what, ma?
You have 1 minute to conclude the presentation.
Okay, how much time?
10
Okay,
minutes.
for the simulation setup here, I use the adaptive fuzzy genetic algorithm control under the variable conditions. So these things, soil moisture, temperature, and humidity are used as the input values. So here this correlation analysis, how each and every variables are highly correlated and not correlated. So performance comparison, here I taken this 3 existing models to compare with my proposed model, threshold value, standard fuzzy, and conventional fuzzy with the genetic algorithm. Here water is reduced to 18% in this existing model. Then mean error also reduced to 3.0%. Convergence iteration take 90 iterations only. Computation time, here due to more computation steps, we takes more computation than these first 2 methods. Here this performance given this, that is a convergence curve depends on the fitness and generations. So it is just visualization only, soil moisture tracking system. For this soil moisture and time, here this green line shows the target moisture, then observed moisture shown in this red line. So this water use efficiency also increased than the existing methods compared to threshold based standard fuzzy and existing method. At the same time, this water usage also reduced here. Here, this is model validation depend on predicted soil moisturizer and observed soil moisturizer. With this best fit line, it is the green color shows the best fit line. So both are highly related to that best fit line. So here irrigation findings, here how much water consumption and energy consumption for the proposed method of fuzzy genetic algorithm. So when we compare to previous existing method, it used less water consumption as the same time taken also. The conclusion and future proposed for efficient water management, the membership functions and rule based also target level. Only 18% of water savings are achieved compared to the existing methods. The current validation is limited to simulation based testing conditions only. Future work includes field deployment using IoT based real time sense and hybrid adaptive genetic algorithm variants will be explored large scale farmings also. Thank you.
Thank you so much for your presentation. Sir, do you have any questions? Sir, do you have any questions?
Yes. I have one question. Jaya, can you explain me how these genetic algorithm are used to optimize the fuzzy rule parameters?
I don't understand now how genetic
Yeah,
algorithm
yes.
works. I'm actually first here. I'll go to that store. Yeah. Here, first we are taking the sensor data, ma'am. Sensor data directly. Actually, we are getting the normal numeric data only, soil moisture, temperature like this. Then this data here, we know this here linguistic values. The linguistic means low value, mean and high values. So these values converted based on this rule based. Then the same values we have to actually have to get proper out tune out these values. Tuning means with the help optimize these values. So here we have four steps. So first step initial we have the initial population. From the population with the help of this outlet wheel selection. First we select the best parent with the help of the fitness function. So with the help of fitness function we select the best parent. Then we are going for this crossover operation, generate the new offspring. New offspring means which is a new children. So based on that we are producing this optimization mutation function.
So, any other questions?
No. I have done from my side.
Okay. Thank you so much for your presentation, Jaya. Okay.
I hope all groups are completed.
Yes, sir. I'll just do the conclusion now. I sincerely want to thank our authors for their excellent presentations and contribution in the session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on the behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters will be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. So kindly cooperate with the team of ICTCS 2025. Before ending this session, I would like to take a moment to thank our session chair, Professor Jitendra, for chairing this session. So, this is a token of appreciation to the chair on the behalf of the whole team of ICTCS 2025 and Global Knowledge Research Foundations and partners. Would you like to share a quick closing remark with us?
Yes, thank you. Thank you so much. Just share this certificate on the email.
Yeah, sure, sure. I would request everyone
Yeah.
to kindly turn on their cameras for a quick snapshot before we end this session.
मला पण हरवलं
Everyone,
आहे.
all the participants, kindly turn on your cameras. Thank you so much, everyone. Stay safe, stay connected. Bye bye.